All right. Hey guys.
I'm Corey.
My name is Miracle, and my goal is to help raise the vibrational frequency of the world through knowledge. And if you don't know what that means, then today you will learn. So, quantum mechanics, right? Don't freak out. Don't freak out. Stay with me. Stay here. Stay with me. Quantum mechanics seems like the most complicated subject, right? But it doesn't have to be. Nothing has to be complicated if it's broken down in an easy to follow way. I like to cover topics that they don't but should cover in public school. And also things that a lot of kids might not truly grasp, but they don't want to be that person to raise their hand. You know what I mean? Like, do you know what I mean? Where you would like just days off and then you're like, you realize you're on the wrong page and you missed like the most important opening concept of the subject and now you're lost for the rest of the entire lecture. I love learning, hated school. So anyway, quantum mechanics. This is very relative to my channel because you must have some grasp on quantum mechanics to truly utilize the law of attraction. The law of attraction is actually a secondary law, the law of vibration being the primary principal parent law. Law of vibration being the parent law. This is that everything is in a constant state of vibration, and quantum mechanics can help you understand that better. Remember, quantum mechanics is not scary. There are these videos that try to explain it with like a cat and a marble going through a hole, and then you finish the video and you're like, what the heck did I just watch?
This means that we can never simultaneously know both the position and the momentum.
And I've seen that video so many times and I just can't get it. I leave more confused than when I began the video. I leave with more questions, you know? It just doesn't do a good job of making it simple. Which is when learning becomes a chore and then people avoid tough subjects because it's intimidating. Evolution is efficient, and so people will take the path of least resistance because it is smart, not lazy. Also, I'm not trying to oversimplify or understate the work of scientists. I love them very much. I just think this is something people should know. So, let's define terms to start off. This in itself should answer a lot of questions. When we look up the word quantum, it says, a discrete quantity of energy proportional in magnitude to the frequency of the radiation it represents. What does that mean? What the heck does that mean? See, they don't make it easy. All right, so a long time ago, in a galaxy far away, they thought the atom was the smallest thing ever. Then technology improved, consciousness grew, and they discovered that there was something smaller. We got the electron microscope, we discovered protons, neutrons, neutrinos, and then there would be the next awesome discovery for the thing that would be the smallest thing. Scientists were like, yes, this is it. This is the thing. This is the smallest thing. But now they see that the rabbit hole just keeps on going. And I have something scary to tell you. It just goes for infinity. Yeah. The universe is a fractal infinite continuum. Infinitesimally small to infinitely large. It looks like this. So the smallest particle, it's an idea. It really doesn't exist, does it? And this is what quantum means. A quantum is the smallest possible particle in theory. It's a placeholder, like a variable. And this is where the term subatomic comes from. Smaller than an atom. Subatomic, smaller than an atom, right? Don't freak out. Don't freak out. It's okay. I know it's pretty mind-blowing stuff. It's okay. Stay with me here. Just kidding. I'm not gonna get too into this because it will literally blow your mind out like speakers. So how about I just explain why this is important for you to know. The world is made up of tiny little baby quantums. You can call them energy, you can call it air. Air, you know? That thing that is there, but we can't actually perceive it, but we know it's there. We know that it's made up of elements, it surrounds us. We just don't perceive it the way we do a ball, a solid object, physical object in the human realm. A fish doesn't perceive water the way that we can perceive the water. Just like how we don't perceive the air that we're in, like a fish doesn't perceive the water that it's in. But it's definitely there. We know it's there. So these quanta are in a constant state of vibration. You are made up of kajillions of quanta constantly vibrating. The world is much bigger and much smaller than we can fathom. Hey Ravens! A good way to picture it is thinking of the world as pixels and you're just zooming out on your smartphone, just zooming out forever or zooming in forever. So something hard, like a table, just has vibrating quanta that is more tightly packed than something more flowy like water. Objects that are different simply have quanta that behaves differently. Thoughts are also quanta, or energy. Everything is energy. And I'm going to do a separate video on this, of course. But to truly utilize the law of attraction, you must change your quanta, vibrate faster and higher. You see, the universe doesn't understand language the way we do. If you're sad and you're like, well, law of attraction, I'll just fake it and say I'm happy. It doesn't work that way. Although the word happy itself has its own vibration that is high, if your feelings don't line up, the universe doesn't read it correctly. Like a radio frequency between channels, it's like fuzzy connection. Frequency is simply a way to measure the vibration of particles. So 528 hertz, for example, is a quanta making 528 revolutions per second. Now, so think of a guitar string. You strike it. And what is happening when you hit the string, you see that. Let's say this were 500 hertz. It would be 500 of 500 movements of the string back and forth, producing a sound wave that hits our ear and we hear the note. Hi, Rex. And so if I raise the pitch, so the pitch is low, right? See it? If I raise the pitch, it's simply higher vibration, faster movement, faster vibration, higher frequency. The piano, so here's something crazy. This is mind-blowing. So what I'm about to tell you is completely mind-blowing. You take a piano, right? And a piano is similar to a guitar, where instead of striking the string with your finger, you hit a key on the keyboard and a hammer strikes the string. So it's the same thing. It's just a bigger string for the low end, a bigger string for the low notes, and then a smaller string wrapped more tight and tight and tight. Tighten the chord, raises the pitch, and then raises the frequency. Just goes higher and higher and higher. So take that piano, right? 88 keys. If you were to add 300 keys to the end of that piano, just keep going. Keep on stretching that string out, right? Tighter and tighter and tighter. Tighter and tighter and tighter. If you hit the D key on a regular piano, you hit that after adding 300 keys with that super stretched out string, you would see the color blue. You would see the color blue. You would see the color blue. And that is how a light bulb works. hold up. The note D correlates with the color blue. Remember in my last video I told you that everything is that rainbow pattern repeating over and over and over again. That's all that is. See, if you take a frequency, it's at the lower end of the spectrum, you can see the visible light. That's all that light is. It's just a very, very high frequency. You have a lower frequency and it's a sound wave. You make that tighter, raise the frequency, it becomes a color, then it becomes different kinds of waves. It becomes X-ray, gamma ray, microwave. That is the frequency spectrum. That's how you read that. That's how you understand that. More on that in another video too. I've got so much stuff for you guys. So, crappy feelings vibrate at a lower frequency. Happy, joyful, enlightenment feelings, violet, the top of the rainbow spectrum, that is very high, very fast, very good, uplifting frequency. And now, I never understood frequencies in school. That was like the one thing that just boggled, one of the couple things that just boggled my mind. I'm like, I don't get it. Frequency, what are you talking about? But then I was that kid that I didn't want to raise my hand. I didn't want to look stupid. So I was like, oh yeah, I get it. Sine waves, oscillator, I get it, yeah. Cool. I'm on the same page here, yeah. So frequency is usually depicted as that sine wave, right? But it's really much more complex than that. That's just a two-dimensional version of it. It's a three-dimensional thing though. And that is a two-dimensional representation of it. So that would be oversimplifying it. And that's why it's hard for us to grasp. But for simplicity's sake, when they say a revolution or cycle per second, zoop, cycle per second, just think of a ball. One cycle of a ball. Let's see, what do I have here? Ball, like ball. Alright. So here's your quanta, right? It's just one spin of the ball. Zoop, zoop. Quantum. Quantum is singular, quanta is plural, by the way. Quantum. Okay, so that's all I have time for today. I hope you enjoyed that. I can definitely keep going on the topic. I really want to make sure you understand it and aren't that kid that doesn't want to raise your hand. I'm here for you. Don't worry. I'm here for you. All right. Well, see you next week. Bye.
Everything small is just a small version of something big. I understand everything.